A, B and C of masses 4 kg, 2 kg and 1 kg respectively are in contact on a frictionless surface as shown. If a force of 14 Newton is applied on the 4 kg block, then the contact force between A and B is. Okay, so this is actually a question from the chapter Laws of Motion. Okay, so let's see how to do this question now. So in the question, we are supposed to find out what is the contact force between blocks A and B. Okay, we are supposed to find out what is the contact force between blocks A and B. Okay, so in order to find the contact force, the first step that we are going to take is, we will be considering all the three bodies together as a single body. So when we take all the three bodies together as a single body, what will be the total mass of this body? 4 plus 2 plus 1. What is that equal to? That will be equal to 7 kg. So A, B and C are taken together as a single body of mass 7 kg on which a force 14 Newton is applied. Now it is very clear from the question that the blocks are resting on a frictionless surface. So you don't have to bother about friction over there. Okay. Now how do you find the acceleration of the system? Now they are moving in this direction with an acceleration A. So I can write, based on Newton's second law, F is equal to ma. What is F? 14 Newton, right? So 14 is equal to 7 into A, or acceleration you will be getting it as 2 meter per second square. Acceleration is equal to 2 meter per second square. Okay. Now, we are not supposed to find the acceleration there, are we? We need to find out what is the value for the contact force. Now, to find the contact force, we will be drawing the free body diagram of this 4 kg mass. So, a free body diagram means we will have to represent all the forces acting on a body and choose a corresponding axis, then write the corresponding force balance equation. Okay. So, I am taking this 4 kg mass, and remember one thing, you can also take this 2 kg mass, no problem. But the only thing is, if you want to take this 2 kg mass and analyze it, you will have to find out first what is the contact force between this 2 kg and 1 kg. Then only you will be able to proceed to find out what is the contact force between A and B. So therefore, it will be easier to take 4 kg mass first and do it. Okay. So what are the forces acting on this 4 kg mass? 1. There is a force of 14 Newton acting on it. Okay. And please remember that the contact force, when we draw it, it is always acting towards the body which we are considering. If we are considering 2 kg mass, it will be towards the 2 kg mass. If we are considering 4 kg mass, it will be towards the 4 kg mass. Okay. So I am marking a contact force C over here, and there is an acceleration for the system also. Now, an appropriate axis I am choosing. Now the axis I am choosing is this. Towards the right I am taking it as positive, towards the left as negative. Above the axis I am taking it as positive, below the axis I am taking it as negative. Okay. So I am going to write the force balance equation along the horizontal direction. So as you can see, 14 Newton is towards the right, taking it as positive, 14. C towards the left, so minus C. Any other forces acting along the horizontal? No, right? Mg and normal reaction is there, but that is in the vertical direction. We don't have to write that equation in this question because it is C, that is one of the horizontal force which we have to find out here. Okay, so 14 minus C will be equal to 14 minus C will be equal to, because of these forces acting on the body, there is a corresponding acceleration A, right? So this is equal to MA. That is equal to MA. So what is M? You can substitute the value. 14 minus C is equal to 4 into, what was the acceleration? 2. So into 2. Or from here you can get C is equal to 14 minus 8. That will be what? 14 minus 8 will be 6 Newton. So the corresponding contact force between this 4 kilogram mass and the 2 kilogram mass, that is between bodies A and B, is equal to 6 Newton. Okay.